Hi boys and girls, since we are going to be learning about aquatic creatures over the next several days, and aquatic means water, let's do an experiment with water today. We're going to decide if something can sink or float. You'll notice behind me I have the word sink and float. I put sink a little further down to represent that sinking means it goes down, and float is a little up higher to represent that it goes to the top. Now, for this experiment, you'll need a container of water, something large enough that you can fit some objects from around your house. So I've got this glass container full of water so that you can hopefully see whether something sinks or floats. And then I gathered up a bunch of objects around the house, things that I wanted to test out to see if they would sink or float. Now, you can do this experiment at home. If you want to follow along with me right now, I want you to get a card and write sink and a card that says float. Can you write those two words down on a piece of paper? And every time I hold up a new object, I want you to make a prediction. I want you to hold up either the word sink if you think it's going to go down to the bottom, or float if you think it's going to stay at the top. The first object I have are some coins. I've got a quarter, a nickel, dime, penny. Do you think they're going to sink? Or do you think they're going to float? Can you hold up your card? Okay, let's test it out. I wonder maybe if some of them will sink and some will float, depending upon what kind of coin it is. Oh, can you see? They all sunk. They went right to the bottom. Okay, well, I'm gonna get those out. Might be a little trickier than I thought. And I'm gonna put those over here on the side that says sink. All four of my coins. It didn't matter if it was a quarter, a dime, nickel, they all sank to the bottom. Okay, well, I've got this marshmallow here. My kids love to eat marshmallows. What do you think, sink or float? Hold up your sign. Okay, let's see. Oh, the marshmallow is floating. It's staying on top. Now, I wonder if we were to leave it in there for a long time, if it would eventually start to sink or maybe just dissolve. But right now it's floating, so we're gonna put it over here on the side that says float. Were you right? Did you guess float? I've got some leftover jelly beans from Easter, and I wanna put those in. I'm wondering if they will sink or float. You make your prediction. I'm making mine. I think they're gonna sink. Oh, they did. They went right down to the bottom. Do you see them down there? Okay, now I gotta dig them out of there. And I'm gonna put them over here on the side that says sink. They went to the bottom. Well, what about these goggles that I had on earlier? Do you think those would sink or float? I know I've lost goggles before in the water, and I know that sometimes they stay at the top and they float for a little bit, but then if the water starts to get in, they start to sink. So I wonder if the same thing's going to happen. Well, let's test it out. Well, they're floating right now. They're floating. Now, I wonder if I were to press on it just a little bit and cause it to fill with water, if they would start to sink. Oh, did you see that? They are starting to sink because there's water that's weighing it down. So, that's kind of a tricky one. They were floating at first, but then they started to sink. Maybe we can keep that here in the middle. What do you think? Right between sink and float, because it did a little bit of both. I have this apple here. Do you think an apple will sink or float? Can you hold up your guess? Okay, let's test it out. Oh, I thought it was gonna sink, but check it out. It is floating. It's floating at the top. So let's take our apple out. Did you guess float? Oh, it's really heavy, but it floated. Okay, let's see. I've got this, I don't know if you call this a little scrub brush for in the shower. I wonder if it'll sink or float. What do you think? Let's test it out. Oh, wait a minute. It looked like it was going to float, but as it fills with water, it keeps going down more and more. I'm wondering, since this is filling with water, if it would just keep sinking to the bottom. So I think we're gonna have to put this on the side that says sink. We'll put this over here. We've got our goggles still in the middle. I have some Legos. I wonder what Legos will do. This is a flat piece. Do you think it'll sink or float? Let's test it out. It's floating. The Lego is floating. I hope you come up with some cool things that you can test at your house, some things that might sink or float. Let's do just a couple more. I've got this glue stick here. Wondering if it'll sink or float. I think it's gonna sink. It's floating. Oh my goodness. Well, I made a prediction, but I was wrong. And that's what happens sometimes in a science experiment. Sometimes you might make a prediction and you might be right, or you might make a prediction, you might be wrong. This was floating, so I'm gonna put over here on float. Well, let's see, I've got this bar of soap that I'm going to unwrap. Do you think this bar of soap will sink or float? Have you ever taken a bath in the bathtub? What does the soap do? If I can get this soap to come out, my hands are so wet and slippery right now. Okay, it's almost out. Okay, we've got this bar of soap. I know that my soap usually sinks to the bottom. Let's see. Oh, yep, it went to the bottom. The soap sunk. Let's put it over here. Okay, how about we try two more things? I've got this straw, and I'm noticing that it's hollow on the inside. So I'm thinking maybe it's going to float. That's what I think it might do, because it's holding some air that is lighter than the water. Oh, wait a minute. It was floating, and then it got some water and it started to sink, but then it stopped. It is still floating, even though it has water in the inside. And I know you probably can't see, but I can see an air bubble on the inside of that straw. I bet that air bubble is helping it to stay afloat. Well, this straw floated. Okay, let's do this paper cup. This is our last thing we're gonna test out together, and then I want you to round up some objects around your house that you can test out. This cup is pretty light, and I know that if I were to set it in this way, it would be holding air, and that air is really light. But I also know if this cup starts to tip over and fills with water, that water would push it down. I think it might do a little bit of both. I think it might float and sink. So let's see. I'm gonna set it in there. It is floating right now. Oh, I see the back end starting to go down a little bit. I'm gonna push on this just a little bit and see if it fills with water. Oh, as it fills with water, it's going down a little bit more. Oh, it's sinking, sinking. It was just like the goggles. It floated at first, but as it filled with water, that water weighed it down, and now it is sinking. So I think I'll put this here in the middle with the goggles. Well, we discovered that some things sink and some things float. I want you to test out some objects around your house, and stay tuned for this little video that explains why some things sink and some things float.
Kids want to know. Have you ever taken a bath or played in a swimming pool, lake, or ocean? Maybe you've noticed that there are some things that make really good bath or pool toys, and other things, well, not so much. The term buoyancy refers to how well something floats or sinks. If something is able to float, we would say that it's buoyant. So, what makes something float or sink? Generally, we can determine if something can float by feeling its weight. Usually, if something is light, it floats or is positively buoyant. If it's heavy, then it sinks or is negatively buoyant. This is an easy enough explanation for us to accept, right? But the idea becomes shaky when we consider why something really, really heavy, like a cruise ship, is able to float. To understand this, we need to understand the concept of density. Density is the amount of stuff or mass something has inside of it, compared to its volume or size. For example, if we look at this bucket full of sand, we would say that it's more dense than this identical empty bucket, because the bucket full of sand has more stuff. It's got more mass. Another example is this bowling ball. It has more mass than a basketball because a basketball is full of air, but a bowling ball is full of stuff. So even though the bowling ball is smaller, it's more dense than the basketball. So what does this have to do with buoyancy? The next concept we need to tackle is called Archimedes' Principle. Archimedes was a mathematician and philosopher who lived in ancient Greece. He had been stumped on a problem he was trying to figure out for the king, so he decided to take a bath. When he was sitting in the bath, he noticed that the water level rose when he went into the bath. Let's pretend that this block is Archimedes. See how the water level goes up when the block goes into the water? This means that in order to make space for his body in the bath, the water had to get pushed around in the bath, making the water level rise. The story goes that he was so excited by this discovery that he jumped out of the bath and ran naked down the street to his laboratory, shouting, "Eureka!" which means, "I've got it!" Basically, what Archimedes' principle helps us to understand is that if an object is heavier than the amount of water that it's displaced, or is something very dense, the object will sink, like the bowling ball. And if the object is lighter than the amount of water it is displaced, or something not very dense, the object will float, like the basketball. So, back to our cruise ship problem. Even though a cruise ship is very heavy, it's also very, very large. Most of the ship is also hollow, so it's not as dense as you might think. Because of this, just like the basketball, the ship is actually lighter than the water it's displaced, causing it to float. Did you know? Submarines dive by allowing water to fill part of the submarines, called ballasts. The air gets vented out until the density of the sub is enough to make it sink. Ships also use ballasts for balance. Without them, they have a tendency to tip in windy weather. Thanks for watching, and don't forget to subscribe.